Hello friends, now let's move on to next topic, different operations on matrices. So like numbers, we can add matrices, we can subtract matrices, we can multiply matrices. All these operations we can do with matrices as well. So let's go on them one by one. So the first thing is matrix addition. So when we do matrix addition, basically we add the corresponding elements of the matrix. Like 1 will be added with 5 to give us 6 here, and the second element 2 will be added with this corresponding element of the matrix to give us the final value in the resulting matrix, right? So similarly, like 4 plus 8 gives us 12, 5 plus 9 gives us 14. So basically the addition of two matrices A m cross n and B m cross n gives us a matrix C m cross n. So the requirement for addition here is that both the matrices should be of the same order, right? We can add 2 by 2 matrix with only 2 by 2 matrix, and similarly 3 by 3 matrix with only 3 by 3 matrix, right? They should be of the same order. The elements of C are sum of corresponding elements in A and B, like we have shown here. So this is all about matrix addition. Let's look at some important points for matrix addition. The addition of matrices is commutative, which means, what does this mean? Like let's say this is matrix A and this is matrix B. If we add A with B, A plus B, or we do B plus A, right, it results in the same result. It results in the same matrix, right? So this is called commutative property. So that's the commutative property. Now next, addition of matrices is associative, which means A plus B plus C equal to A plus B plus C. Basically it means, let's say we have three matrices. Let's say we have a third matrix here, which is 1 2 3 4. Let's say this is a C matrix, and we add the C matrix to A plus B. Now if we add first B and C to get the result, which will be again 2 by 2 matrix, and then we add it with the first A, right? So we are performing this operation A plus B plus C in two steps. First step will give us the result of B plus C. Let's say this is the first step, and second step will be A plus the result of B plus C. If we do it in this way, or if we do it like this, we add A plus B, let's say this is the first step, and add the result to C, which is the second step. So basically it's associative. Either we add A plus B before adding it with C, or we add A plus C before adding with B. Whichever way we do, we are going to get the same result, right? Like in normal numbers we do, let's say if we have to find 1 plus 2 plus 3, so even if we add 1 with 2 first, it becomes 3. 3 plus 3 will give us 6. Or if we add 2 with 3, it will give us 5, and 1 plus 5 will also give us 6. So similarly the matrix addition is also associative, right? Now moving on, the order of matrices A, B and A plus B is always same, as we have seen. Only then we can add, right? If A and B have the same order, and it will also result in a matrix of a same order, because we are adding the corresponding numbers of both the matrices. So it will result in a matrix of the same order. This point is also clear. Now if order of A and B is different, A plus B can't be computed, right? This is an important point which you should note. If some question comes like that and the order is given to be different, it can't be computed. For a simple reason, where will be add, with what will be add the terms which are missing? Let's say if we have two matrices 1 1 2 3, like this is the first matrix, and we have second matrix like this, Now we can add 1 with 1, 2 with 3, 1 with 1. So what will happen of these terms? With whom, when we will perform this, what will happen with for these? So it cannot be done. So such addition is not possible if the order of A and B is different. The next point is the complexity of addition operation is O m into n, where m into n is order of matrices, right? So this is called the complexity of addition operation is O m into n, where m into n is order of matrices. So moving on to further to matrix subtraction. So matrix subtraction is also similar to the basic subtraction we do in mathematics, right? Like 5 minus 1 is 4, 3 minus 2 is 1. Similarly, the only thing is we just subtract the corresponding elements, right? Like if we have two 2 by 2 matrices A and B, and we have to perform the subtraction of these two matrices. What we will do, we will subtract the corresponding numbers. Like the first element of the first row will subtract the first element of the first row. Similarly, second element of the first row will subtract the second element of the first row of B. So we are getting 5 minus 1 4, 6 minus 2 4, similarly 8 minus 4 4, 9 minus 5 as 4. So it's a basic, very straightforward basic idea of matrix subtraction. And let's go over the key points. The subtraction of matrices is non-commutative, which means, yeah, this is the important point to note. It's non-commutative, right? Why non-commutative? You can directly see if we subtract B from A, or let's say we subtract A from B, now what will happen? We'll get 1 minus 5. So B minus A will give us 1 minus 5 will give us minus 4, 2 minus 6 will give us minus 4. So everything will become negative in this example. So A minus B is not equal to B minus A. So the subtraction of matrices is non-commutative, right? It's a very straightforward concept. Similarly, subtraction of matrices is non-associative, right? This will also yield us a very different results. These two operations, let's say first we do this and we do this, these will be totally different operations, just because of the same reason we just saw for A minus B and B minus A. It will give us negative terms and the results will be quite different for both of them. So this is another important property. Subtraction of matrices is non-associative. Now moving on, the order of matrices A, B and A minus B is always same, similar to the addition of matrices. Because why it will be same? Because when we will subtract one term of one matrix from another, it will result in one term only. So when we will be performing the same subtraction operation for all the terms, we will get the same number of terms. So the order will remain the same. So third point is also clear. If order of A and B is different, A minus B can't be computed. Just for the same reason we saw here for addition, right? Here we saw that if the order is different, we cannot do. Similarly, what will happen? What result we'll get if there is no term, basically null? The minus something will yield us nothing. So A minus B can't be computed. The next point is the complexity of subtraction operation is O order m into n, where m into n is the order of matrices, right? So we are done with subtraction of matrices as well. As we move along, we'll see more and more examples on addition and subtraction, but let's now look at the matrix multiplication. The multiplication of two matrices A m cross n and B n cross p. This m cross n is the order of the matrix A, n cross p is the order of the matrix P, gives us a matrix C m cross p. So here the common n will get removed and we'll get a matrix of different order m cross p. So for example, if we have a matrix of 2 cross 3 and B of 3 cross 4, what we will get is the third matrix of order 2 cross 4. right? So this is the important point to be noted for matrix multiplication. So continuing further, it means number of columns in A must be equal to number of rows in B to calculate A cross B, right? So um, number of columns in A must be equal to the number of rows, right? So let's take an example. As we have already taken here, we have a matrix of 2 by 2, and here again we have a matrix of 2 by 2. So the number of columns of A is 2, right, and number of rows of B is also 2, so we can multiply it. So how we will multiply is basically we'll multiply 5 with 1. I will write down here again 5 into 1 plus, now I'll take the second element of first row of first matrix and multiply it with second element of first row of second matrix. So I'll get 6 into 4, which gives me 5 plus 24, 29. So in this way I get the first element of first row of the resulting matrix. Similarly, to get the second element of the first row, I'll multiply 5 with 2. Let me just write down here 5 into 2 plus 6 into 5, which gives me 6 5 is 30, 5 to the 10, I'll get 40. So I got the 40. So this is the process of this one with this one and this one with this one, right? So this is the process of doing the multiplication, right? So similarly, how I will get this element, let me write down here 8 into 1. Now I will take the second row of first matrix and first column of the second matrix. 8 into 1 plus 9 into 4, which gives me 38 plus 36, which is 44. So I got 44. Similarly, to get this element, I will take second row of first matrix and second column of second matrix. So I will get 8 into 2 plus 9 into 5, which gives me 16 plus 45, and it gives me 61. So that's how we have to do multiplication. This is the general formula for that. Like, we'll just multiply the corresponding elements of the corresponding rows with corresponding columns and add them to get the final element. Now you can try it with taking different example of, let's say 1 2 3 4, and let's say 2 3 1 1 2 3. So this is this matrix is of 2 by 2 order, and this one is 2 by 3 by 2. So we'll have to have one more element here to perform the multiplication, because the number of columns of one matrix should be equal to number of rows in the second column. Only then we can multiply, right? This is the important point we have to note here. Number of columns in A must be equal to the number of rows in B to calculate A cross B. Let me highlight it with a different pen here so that you can remember it, because this is the most important point for matrix multiplication, and how we have to perform the operation that I have already explained in detail. Similarly, we can try for 3 by 3 matrices, right? So moving on to the key points, multiplication of matrices is non-commutative, which means A cross B is not equal to B cross A. It will yield a totally different result. So this you have to remember. Multiplication of matrices is associative, which means A into B into C is equal to, whether you multiply B with C first before multiplying with A, or you multiply A with B and then multiply with C, you'll get the same result. So matrix multiplication is commutative. For computing A into B, the number of columns in A must be equal to number of rows in B. This is again the same point which we highlighted earlier. So most important point, like here we saw, here we have 3 columns, and so in A we have 3 columns, so in B we will require 3 rows for to be able to perform the multiplication. So that's all about matrix addition, multiplication and subtraction. Hope you enjoyed the video. If you like, please subscribe to my channel. I'll keep on posting more and more such videos on engineering mathematics. And thank you so much. Have a great time. Bye.